Japan's desperate chip alliance. Can they really replace China's supply chain? In late October 2025, Japan's Ministry of Economy, Trade and Industry officially finalized a new round of semiconductor industry subsidies totaling 1.2 trillion Japanese yen, approximately 60 billion renminbi or $8 billion US dollars. Over 70% of this funding is directed toward the domestic chip company Rapidus and collaborative projects within the Chip4 alliance. This move not only brings the Japanese-led Chip4 semiconductor alliance back into the global industry spotlight but also exposes Japan's urgent desire to decouple from China. In the semiconductor sector, this technical alliance, formally established in early 2024 under the guidance of the U.S., includes the four core semiconductor powers: the United States, Japan, South Korea, and Taiwan. From its inception, it shed the disguise of technical collaboration and adopted a clear exclusivity label. Its core objective is to bypass China across the entire industry chain, including chip design, manufacturing, packaging and testing, and equipment and materials, by unifying technical standards, sharing capacity data, and restricting technology circulation. The goal is to build a secure supply chain system that completely circumvents the Chinese market and its manufacturing capacity. However, when we penetrate the fog of policy promotion and scrutinize this seemingly aggressive, politically backed de-Sinicization movement from multiple dimensions, including technical R&D progress, the depth of market reliance, cost control logic, and supply chain integrity, we find that it has been caught in an inescapable systemic dilemma from the start. Technical bottlenecks, Rapidus's anxiety of catching up, from collaboration halo to autonomy dilemma. As the central pillar of Japan's semiconductor revival plan, Rapidus has been pinned with high hopes since its founding in 2023, with Japanese Prime Minister Fumio Kishida calling it the guardian of national technological sovereignty. Its 2nm chip project is regarded as a potential breakthrough largely due to its technical partnership with the U.S. company IBM. The two parties signed an agreement in 2024, licensing IBM's GAA, Gate-All-Around, technology to Rapidus. This led outsiders to mistakenly believe that Japan could rapidly join the advanced process ranks. However, a technology license does not equate to mastery. Rapidus's announcement in 2025 that it had successfully taped out a 2nm GAA test chip was essentially an assembly-style achievement, completed with design plans and equipment support provided by IBM. Core technical links, such as transistor structure optimization and precision control for photoresist coating, have not yet achieved autonomous control. A more severe challenge is the huge gap between R&D and mass production capability. Rapidus plans to achieve 2nm chip mass production by 2027. Still, according to its supply chain partners, the project's current wafer yield can only reach 35%, whereas TSMC's 2nm yield is already stable above 80%. In semiconductor manufacturing, every 10% increase in yield reduces costs by approximately 15%. A 35% yield means that even if Rapidus's products are mass-produced, they will not be commercially competitive. The promise of a 50-day fast turnaround production efficiency is based on the idealistic assumption of a single client, fixed orders, and its lack of supply chain coordination capabilities will be exposed when facing diverse market demands. Furthermore, the planned capacity of 25,000 wafers per month is not only far below TSMC's Kaohsiung factory, 600,000 wafers/month, but is insufficient to meet the incremental demand for automotive chips in Japan itself. Toyota and Honda's advanced chip procurement alone reached 400,000 wafers per month in 2025. Rapidus's capacity cannot even cover domestic demand, let alone compete globally. This technological generation gap anxiety is not unique to Rapidus but is a microcosm of Japan's entire semiconductor industry. In the 1990s, Japan's semiconductors accounted for over 50% of the global market, with companies like Toshiba and Hitachi leading the world in DRAM technology. However, as the consumer electronics market shifted towards smart devices, Japanese companies stuck to traditional chip manufacturing ideas and gradually fell behind in emerging fields like mobile and AI chips. For power semiconductors, for instance, Japan's Mitsubishi Electric and Fuji Electric once monopolized 60% of the global IGBT market. Still, Chinese companies achieved breakthroughs in the 1200V 1700V medium to high voltage IGBT sector through an introduction digestion innovation model. BYD Semiconductor's automotive-grade IGBT yield has reached 95%, with prices 20% to 30% lower than Japanese counterparts. Its global market share rose to 18% in 2025, directly squeezing Mitsubishi Electric's market space. The talent gap problem further exacerbates the challenges for Japanese companies. The Japanese semiconductor industry saw investment contraction after 2000, with core R&D talent flowing heavily to Silicon Valley and Taiwan. The average age of semiconductor engineers in Japan is currently 48, with personnel under 35 accounting for less than 15%. In contrast, the average age of R&D teams at SMIC and Huawei HiSilicon is only 32. Market shackles, the indispensable Chinese base. The fatal weakness of the Chip 4 alliance is its deep reliance on the Chinese market. China is not only the world's largest semiconductor consumer market, but also the source of significant production capacity and profit for core alliance members like Samsung and TSMC. Samsung's chip business profit plummeted by 94% in the second quarter of 2025, mainly due to restricted sales to China, with its factories in Xi'an and Suzhou struggling with inventory buildup due to equipment import restrictions. TSMC faces a similar dilemma. Its Arizona factory is mired in losses, while its Nanjing factory remains profitable despite strict restrictions. The strategic value of the Chinese market is self-evident. This reliance stems from the natural division of labor in the industry chain. As the world's largest electric vehicle market, China supports the huge demand for power chips. Simultaneously, local companies continue to lower costs through scaled production, further consolidating their market position. Jun Okamoto, an analyst at KPMG, points out that emerging Chinese chip manufacturers can rapidly iterate products using customer data. This positive demand R&D cycle is an advantage that alliance members find difficult to replicate. Cost trap, the economic price of de-Sinicization. The alliance's attempt to reconstruct the supply chain is facing a backlash from high costs. China's cost advantage in semiconductor manufacturing comes from its complete industrial ecosystem and energy advantage. Energy costs alone account for 30% to 40% of the cost of manufacturing semiconductor substrates, and China's lower energy prices give local companies a natural edge in substrate production. In contrast, Japan's Rapidus factory relies on imported equipment and energy, and TSMC's U.S. factory construction costs have doubled due to soaring labor costs. These extra expenses will eventually be passed on to the final product. The vertical integration model of Chinese enterprises further amplifies the cost advantage. Japanese companies are accustomed to end-to-end internal production, while Chinese manufacturers focus on core links to improve efficiency. This division of labor has already been effective in the silicon carbide substrate market. Chinese companies now dominate this field, forcing Japanese companies into a price war dilemma. David Dye, an analyst at Bernstein, stated bluntly that Japanese companies have either overestimated their domestic market or misjudged their own competitiveness, and are clearly at a disadvantage in the cost battle against China. The power of countermeasures, the chokehold advantage of rare earths and materials. China's near-monopoly position in semiconductor materials poses the biggest hidden danger to the de-Sinicization plan. Rare earths are key materials for chip manufacturing, and China holds an absolute dominance in the global industry chain, accounting for 37% of reserves, 70% of production, and 90% of smelting and separation capacity, with over 80% of medium and heavy rare earth reserves. More crucially, 92% of the global capacity for the high-purity cerium-containing polishing powder needed for advanced chips of 14 nanometers and below is concentrated in China, while the purity of similar US products only reaches 99.5%, 2 orders of magnitude lower than China's 99.9999%. This industrial moat, created by materials superiority, is difficult to cross. Even if alliance members achieve breakthroughs in chip design and manufacturing, they cannot escape the core material support provided by China. Japan has tried to team up with Australia and India to build a rare earth supply chain, but the lack of smelting technology has rendered this plan merely lip service. Globally mined rare earths still need to be shipped to China for deep processing. Alliance fractures, Samsung and TSMC's no-win choice. The internal conflicts within the Chip 4 alliance are escalating. Samsung and TSMC are forced to choose between following the US and preserving the Chinese market. And reality has provided a harsh answer. TSMC's US factory production has been delayed until after 2027, and Samsung's Texas factory is also behind schedule.